Multiplying radicals. When we multiply radicals, we can take the two radicals that are being multiplied together and write it as one big radical with the two radicands being multiplied together underneath that radical sign. Now there is one condition. Both of those two radicals have to be positive, because remember, we cannot square root a negative number. No, for our first example, we have square root of 3 times square root of 5. So we could rewrite that as the square root of 3 times 5, and then multiply our radicands together. 3 times 5 is 15, all under the radical sign. And there's our final answer. Just like when we add and subtract, sometimes our radicals will have coefficients in front of them. And if there's a coefficient in front, we're going to multiply the coefficients together, and we're going to multiply the radicands together. So it's going to be outside times outside, underneath times underneath. This question has coefficients in front of both radicals, so we're going to multiply those coefficients together, and we will have 4 times 2. And then under the radical sign, we are going to multiply the radicands together, so 3 times 6. Multiplying 4 times 2, that gets us 8. 3 times 6 gets us 18. Now, just like fractions, we always need to reduce our radicals if at all possible. So if we took a look at this, 18 is 2 times 9. 9 is 3 times 3. We have some repeating prime factors, so it looks like it is possible to simplify. So replacing the 18 with 2 times 3 times 3 under our radical sign, we then have an index of 2. So as we look at our index of 2 there, so no visible index is an index of 2. The 2 3's get to go together and they can leave. The 2, however, has nobody to go with, so it has to stay behind. That 3 joins the 8 that was already out front, but the 2 behind. 8 times 3 is 24. Square root 2. So one thing to keep in mind as we look at these questions is that we always need to reduce if possible. And that reducing means lowest radicand. In mixed form. Two is a prime number. It can't get any smaller, so that is indeed our final answer. For this example, we have 2 sets of brackets with radicals in them. Remember, no sign between the brackets means multiply. And we tackle this the same way we would if we were multiplying 2 binomials together in polynomials. We're going to multiply everybody in the first set of brackets by everybody in the second. So if we go and start doing that, that means we're looking at these 2 multiplying together. A positive times a positive is a positive. So we've got 6 times square root of 5. And then we're going to multiply these 2 together. Positive times a negative is a negative. 6 times square root 10. So 6 is now multiplied everybody in the second set of brackets. So it's done, and we can move on to the square root of 6. As we look at our square root of 6, it's going to start multiplying everybody in the second set of brackets. Positive times a positive is a positive. Square root of 6 times square root of 5. And then multiplying these guys together. Positive times a negative is a negative. Square root of 6 times square root of 10. So there's what it would look like if we were to write it without the brackets. As we go to do that, remember, no visible coefficient is the same as having a coefficient of 1. So everybody who has no visible coefficient on them would have a 1 in front of it. So everybody has a 1. They didn't have another number in front of them. So 6 times 1 is 6. This radical has nobody to multiply with, so it's not going to change. It's going to be the square root of 5. We have our minus sign. 6 times 1 is 6. Again, this radical doesn't have anyone to multiply with, so it's not going to change, and it'll stay as the square root of 10. We got our plus sign. 1 times 1 is 1. Remember, we can write the 1, or we don't have to. And then 6 times 5 is 30. And then our last one, we have our minus sign. 1 times 1 is 1. 6 times 10 is 60 under the radical sign. So at this stage, we now have everybody multiplied together. We're going to look to see if we can add or subtract them and whether or not they reduce. So looking at all of our radicals, they all look very different. So cannot add or subtract at this stage. However, we may be able to simplify and may or may not be able to add after. 5 is a prime number, so it's not getting any smaller. Factors of 10 are 2 and 5. Nothing repeats, so it's not going to get any smaller. 30. Let's take a look at 30. So we move off to the side and look at 30. 30 is 3 times 10. 10 is 2 times 5. All the factors are different, so it's not going to simplify. And then our last one is 60. 60 is 6 times 10. 6 is not a prime number. The factors of 6 are 2 times 3. Factors of 10 are 2 times 5. Looking at that one, it does have numbers that repeat, so there is a chance that it will simplify. So as we look at it, the square root of 60 is equal to 2 times 2 times 3 times 5, all under our square root sign. It did have an index of 2, so these two guys get to be circled and move out. We get our radical sign. 3 times 5 is 15. So the square root of 60 simplifies to 2 square root 15. So going back to our work and our question, the first 3 radicals are going to stay exactly the same. We have 6 square root 5 minus 6 square root 10 plus square root 30 minus, we can replace that square root 60 by 2 square root 15. So we've now simplified the ones that simplified, checking to see if any can be combined. All radicals are different, so none can be added or subtracted. So this would be our final answer.